Strong, leak-proof joints in the piping systems of the modern deep-diving submarine are absolutely essential to the safety of the ship and crew. Many joints are made by brazing. Torch brazing is used, as well as induction brazing. To braze by either method, rings of brazing alloy are placed in grooves in the pipe fitting. When the joint is heated, the alloy melts, solidly bonding the pipe to the fitting. To be sure each joint is properly bonded, 2 tests are made. The ultrasonic test indicates the percentage of area that is bonded with alloy in the joint to make sure the joint can withstand severe vibration and the shock of depth charge attack. In the hydrostatic test, water at a pressure 1 1/2 times system working pressure discloses any leaks in the joint or fitting. A joint that fails either test may be repaired if possible and retested. Only 2 attempts at repair are allowed. This film will show how the integrity of brazed joints is assured through inspection and repair. The ultrasonic test, or UT, uses a principle similar to the sonar employed aboard submarines to detect enemy targets. The operator moves the crystal search unit around the joint. High-frequency electric impulses make the search unit mechanically vibrate. The vibrating unit thus transmits sound waves into the fitting and pipe of the joint being tested. If the alloy bond is good in the area being tested, the waves penetrate to the inner surface of the pipe before being reflected back. The reflected waves appear as a trace on the cathode ray screen. The operator marks the location of the bond signals on the scope face. He also indicates where any signals from the fitting's ring groove would appear if the search unit inadvertently moved from the land that he's testing. Also appearing on the scope to the far left is the trace of the initial pulse. This trace isn't used in the testing. If there are voids in the bond, some signals return from the inner surface of the fitting. The trace appears on the screen to the left of the signals that indicate good bond. The operator marks the location. The bond and no bond traces are separated on the screen because it takes a longer time for the bond signal to penetrate the joint, return, and appear on the screen. The operator mentally estimates from the relative heights of the bond and no bond signals the percentage of bond in each area of the joint he's testing. The percent of bond in a specific area of a joint can vary, of course, from 0 to 100. Calibrate your equipment as the first step in effective ultrasonic testing. Use a calibration block for verification of signal position. At each end, the block has 2 lands and a recess groove for the alloy ring, as does a pipe fitting. The pipe land is the area from the outer face of the fitting to the groove. The fitting land extends from the far side of the groove to the shoulder that the pipe seats against. To use the calibration block, apply couplant, such as glycerin, to the area to be examined. The couplant helps transmit energy from the unit into the work. The first trace on the screen is the initial signal transmitted by the search unit. The next trace is the no bond signal. Identify this location, too. The next trace is the bond signal. The signals to the right of the bond signal are simply multiple reflections and not used in testing. Use the appropriate controls to obtain the best possible signal resolution. The gain control allows adjustment in the height of the trace. With the range control, you can stretch out the horizontal placement of the signals. The pulse energy or damping control varies the transmitted power. For best resolution, use the lowest power possible. Some equipment may use the reject control to get rid of grass or extraneous signals. The horizontal lines on the scope face help you estimate percent of bond. As an additional aid, some scopes have numbers at the edge of the screen. When you're ready to actually inspect a joint, make sure its surfaces are parallel and not beveled. Use a felt marker to divide each land into increments or sections. Mark 1/4 inch increments for static scanning and up to 1 inch increments for continuous scanning. Viewing the fitting from the pipe end, number the increments in a clockwise manner. Select a search unit that has an effective beam size large enough to cover one land of the fitting you're testing. If the search unit is too large, you'll get unwanted signals from the ring groove. Place the search unit over one land. If no signal appears, increase the gain. If there's still no trace, try a search unit of a lower frequency. Begin with the unit centered over the first increment mark. In the method known as static scan, a reading is made at regular intervals within each increment. Determine the percent of bond at each interval by comparing the relative heights, or amplitudes, of the bond and no bond signals. Some activities use an overlay which allows direct reading of percent bond. For this interval, for example, the amplitude of the no bond signal is equivalent to 2 units on the grid scale, while the amplitude of the bond signal is equivalent to 8 units. Your estimates of the percent bond are based on the fact that of the total of 10 signal units, 8 units are bond. This ratio of 8 to 10 indicates that the percent bond is 80%. Move the unit to each interval in the increment. Record the average of the readings of the intervals of an increment on the inspection record in the printed boxes. Values should be to the nearest 5%. Test each interval in each increment in both lands and record values after each increment is finished. This is a case of no bond. No trace appears at the bond signal location on the scope. Use the symbol NB, no bond, to record such a value. This set of traces indicates a 50% bond for the interval being inspected. This trace represents 100% bond area. No trace appears at the location of the no bond signal. This is a stripped fitting with 100% bond area. Occasionally, an increment is inaccessible because of the configuration of the fitting. Use an X on the report for such an increment. If the piping blocks a particular increment, use the symbol NA on the report. Record any unusual indications that might cast doubt on the integrity of the joint. Find the total of all the individual increment percentages. Divide this total by the number of increments tested to obtain the average percent of bond for the overall joint. Increment markings for 1/2 inch IPS are the same as used for larger sizes. Use a plastic standoff with the search unit or a special transducer. This standoff provides a time delay that horizontally separates the initial pulse trace on the screen from the other traces. Inspect the joint in the usual manner. If a fitting is the type that has no recess grooves, use a search unit that covers a specific proportion of the area to be tested, such as 1/2 of the area. Make separate circumferential searches, 2 in this case, until all increments are covered. The static technique is just one of 2 possible ways of using the search unit. The other method is continuous scan. To use it, move the search unit from one increment mark to the other without reversing direction or lifting the unit. The traces may show different amounts of bond within a particular increment. Average the bond and no bond signals while scanning the joint. Record your estimate for each increment to the nearest 5%. UT readings as recorded on the inspection report are transferred to the SIL-BRAISE report and become a part of the official record of each joint. The automatic inspection equipment presently being developed utilizes the same ultrasonic unit as used in the manual process. Positioning and rotation of the transducer is performed mechanically at speeds which may be controlled by the operator. Bond amplitude signals are received from the ultrasonic unit and through integrating circuits are presented on a paper tape. The integrating unit will provide recording of the bond at any particular instant and as an accumulative bond condition for the entire joint. Ultrasonic test equipment is portable and finished joints can easily be tested aboard ship. Techniques are the same as for tests made in the shop. If a joint fails the ultrasonic test because it has less than 60% bond, you can try to improve the percentage of bond, providing the joint has never carried liquids other than fresh water. Induction heating can be used or torch brazing. The repair procedure is much like brazing a new joint. Bring the joint up to the flow temperature of the brazing alloy. This will allow the original alloy to reflow in the joint. Face-feeding supplemental alloy when repairing a joint is permissible. Concentrate on that area of the joint that has a low percentage of bond. If you try to repair a joint twice and it still fails the tests, replace it. Before a joint is hydrostatically tested, it must be thoroughly cleaned of flux, inside and out. Otherwise, the flux might temporarily plug up any pinholes or voids in the alloy bond. A joint might pass the hydrostatic test, only to leak later when the flux dissolved. Soaking with wet asbestos cloth will help soften old flux. Use a stainless steel wire brush or scraper to remove flux. Never file or grind, which could damage the pipe and cause rejection. Joints completed in the shop are internally cleaned in the tank room before testing. After cleaning, set up the work on the test bench. Use a test pressure 1 1/2 times the pressure the joint will normally experience under operational conditions. The test inspector inspects the joint for leaks and records the test pressure. This record is included in the inspection report of the piping system. If a fitting is found to be porous during the hydro test, replace it. There's no fix for this condition. In the case of a joint with a pinhole leak, follow the same repair procedure as with a joint failing the ultrasonic test. Piping systems that are to be hydrostatically inspected on the ship are first tested with compressed air. The air helps detect any obvious leaks in the system, such as open valves or missing gaskets. A hot water flush follows. The water should be from 110 to 160 degrees Fahrenheit. Flush for at least 1 hour and follow with a cold flush for 15 minutes. Use a cold water soak only if hot water flush is not feasible. Fill the system with water not colder than 60 degrees and let it stand for at least 12 hours. Follow this with a cold water flush for at least 4 hours. Hydraulic systems are cleaned with hot water followed by a hot oil flush. If the hydro test shows a joint is faulty, repair or replace fitting. Now let's review. Successful UT requires properly calibrated equipment and a careful, accurate inspection of each increment with the search unit. Learn to quickly calculate mentally percentages of bond without written references to a formula. Keep complete records. Successful hydrostatic testing requires the joints be carefully cleaned, outside and inside, to remove any trace of flux. Make 2 attempts to repair joints that fail either test, if the joints have carried fresh water only. Good inspection and repair technique means safe, reliable piping systems for the ships you help build.